although human observations of the vast universe have determined an immense scale. In reality, what we can imagine still seems extremely small. Because recently, astronomers have discovered a monster so large it's unimaginable, a supergalaxy. The LOFA telescope has just released a spectacular image of the largest galaxy ever known. This supergalaxy is classified as a giant radio galaxy, meaning a type of radio galaxy when it stretches across the sky, exceeding the threshold of 2.3 or 3.3 million light-years. Radio galaxies along with their related objects, quasars and blazars emitting radio radiation, are types of very bright active galaxies at radio wavelengths, with luminosities up to 10 to the power of 39 W in a frequency range from 10 MHz to 100 GHz. Currently, only about 1,000 giant radio galaxies have been confirmed, mainly concentrated in the northern sky. The newly discovered super radio galaxy is named Outside Onias, after the greatest giant among the Gigantes giants in Greek mythology who opposed Heracles. Located about 3 billion light-years from Earth, Outside Onias reaches a size of 16.3 million light-years, and is the largest galactic structure ever known in the universe. For comparison, our Milky Way galaxy is also a large galaxy, a monster in the galactic world, but has an estimated diameter of just over 100,000 light. And if compared to Outside Onias, our galaxy would be like a tiny speck. The discovery highlights the limitations in our understanding of these giant monsters, and what drives their astonishing growth. But it may provide another pathway to better understand not only giant radio galaxies, but also the intergalactic environment lurking in endless space. Giant radio galaxies remain another mystery in a universe full of mysteries. Unlike the commonly known image of galaxies, a giant light disk with a supermassive black hole at its heart, or called a monster black hole, this galaxy has a bizarre and terrifying shape. Each of its lobes contains a supermassive black hole, with more black holes forming lobes that help accumulate gas, dust, and stars from the surrounding environment. Its structure in radio images consists of something like a central jet and 2 radio lobes extending outward. Astronomers are fairly certain they know what creates this jet, which is an active supermassive black hole at the center of the galaxy. They call a black hole active when it attracts or accretes matter from a massive disk of material around it. However, not all matter in the accretion disk, when swirling into an active black hole, will definitely cross the event horizon, because a small portion of that matter, by some strange mechanism, is transferred from the inner region of the accretion disk to the poles, where it is shot into space as plasma jets, at speeds close to the speed of light. These jets can travel very great distances before they disperse into lobes, emitting giant radio waves. This process is quite common. Even our own galaxy has lobes. What we don't truly understand is why in some galaxies, they grow to absolutely gigantic sizes, on scales of millions of light years. And that is why they are called giant radio galaxies. And the most extreme examples can be the key to understanding what drives their growth. According to astronomer Martin Royer and colleagues from the Leiden Observatory, Netherlands, if characteristics of the host galaxy are a crucial cause for the growth of giant radio galaxies, then the host galaxies are the largest giant radio galaxies likely possess. Similarly, there are large-scale environments particularly favorable for the growth of giant radio galaxies, then the largest giant radio galaxies likely reside within them. The radio source of this galaxy is sensed all the way to SEO 81421.685224100, an elliptical galaxy 3 billion light-years away, in the Solings cluster, showing how powerful this monster galaxy is. The research team searched for these outliers in data collected by the LUFA telescope in Europe, an interferometer network comprising about 20,000 radio antennas distributed across 52 locations throughout Europe. They reprocessed the data for a new mapping, removing other small radio sources, which could hinder the detection of faint radio lobes and correct for optical distortion phenomena. They say the images are the result representing the most sensitive search ever conducted for radio galaxy lobes. Subsequently, they use the best available identification tool to determine the target. After surveying the radio lobes, researchers used the Sloan Digital Sky Survey to identify the host galaxy. They discovered it is a fairly normal elliptical galaxy located within a filament of the cosmic web, with a mass about 240 million times that of the Sun and a supermassive black hole at its center, with a mass 400 million times that of the Sun. Both of these parameters are at the lowest end compared to giant radio galaxies, and may provide clues about the factors driving the growth of radio lobes. According to the research team, aside from morphology, outsider ONUS and its host galaxy are both very ordinary. With total low-frequency luminosity density, stellar mass, and supermassive black hole mass all lower, though similar to intermediate giant radio galaxies. This suggests that supermassive galaxies or central black holes do not necessarily need to reach ultramassive sizes. And if the observed state represents the source throughout its lifetime, then the radio power is also not high. Therefore, it is possible that outsider ONUS is located in a region of space with lower density than our environment, which may allow it to expand, or interactions with the cosmic web play a crucial role in the development of this superstructure. When looking up at the night sky, stars and galaxies appear to be randomly distributed. However, this is not entirely the case. The universe is not a random collection of objects, but has a structure composed of galaxies and gas. Cosmologists call this the cosmic web. The cosmic web consists of connecting filaments containing concentrated galaxies and gas, stretching across the universe and separated by vast voids. These features give the universe a sponge-like appearance. The largest filament discovered by astronomers to date is the Hercules Corona Borealis Great Wall, which is 10 billion light-years long, one of the largest structures in the universe and contains billions. As for voids, the largest is the Pleiades void, with a diameter of 2 billion light-years. Our Milky Way galaxy lies within a part of this void. However, when zoomed out far enough, this pattern disappears and the universe looks like a homogeneous block of galaxies. The end of greatness. Nevertheless, on smaller scales, we can see that the universe truly has a magnificent structure. This raises questions about the origin of that structure's formation. Overall, the new discoveries by astronomers, along with the mysteries behind them, give the universe a special allure. Thank you for watching the video.